My name is Thomas Binder, and this is session Networking 401, ICE Edge Media Connectivity in Lync 2013. So in this session, we will be talking about the AV Edge server and what it does for us. It's a wonderful component in our Lync ecosystem, in our Lync environment, and it helps us to do media sessions. How is it going to do that? This is what we're going to find out in detail in this session. We will also talk about how do we find the most optimal media path. So if I want to call someone else, if I need to connect to my server, how can we get sure that we are smart in choosing how the traffic flows? Also, during this session, we will learn how we can read the log files. So what can we learn from client logs? And that will help us, well, first of all, to understand what's happening, to see it, and it will help us to troubleshoot later on. So if we have any connectivity issues, in this session, we will go into detail what you're going to see, where you need to look to fix your problems. So I hope this will be interesting. It will be about understanding call flows, and basically, it will help you to troubleshoot. The agenda that we're going to look at is, first we will talk about the challenge. Why do we need an AV Edge server? What is the problem that we are trying to overcome here? And then we will talk about the solution. How can we fix that? And finally, we will talk about the usage of it, look into call flows, different scenarios, and see, again, how all of that manifests in the logs so that we can actually see what is happening. Before we go too much into the topic, I want to introduce myself. I'm Thomas Binder. I'm part of Microsoft since 2007, so I started to work in Microsoft as a consultant in Austria and Vienna. This is where I live, in local MCS, and started in the time frame of beta 3 of OCS and became, well, expert on OCS and Lync. Back then, OCS was still quite new, so I had the chance to work with a lot of large customers. I got also involved in the Microsoft Certified Masters program for OCS and for Lync, so I used to teach at this program, taught about this specific topic, Lync Edge Server, OCS Edge Server, also taught about hardware load balancing, certificates, DNS, everything that's connected here. So today, we will concentrate on the Edge server itself. My role today within Microsoft is I'm not in local MCS in Austria and Vienna anymore. I'm part of a global team. It's called the Enterprise Communications Center of Excellence. And basically my team, we are 20, 25 architects worldwide. We work with all the local MCS teams to help them drive the largest opportunities and to help them being successful in deploying Lync. On the slide, you can also see my email and zip address. That's tbinder@microsoft.com. If you have ever any questions around the Edge server, feel free to reach out to me. I'm always happy to discuss these issues, especially when it comes to AV Edge and media connectivity. In my free time, I like to practice field hockey. Also happy to talk about that, so feel free to catch me later, and then we can have discussions about what's hockey, what's ice hockey, and what else. But for now, let's stay with Lync. One other thing that I want to mention, if you look at the session description, there are two speakers listed actually, so that's me, Thomas Binder, and Brian Nice. Brian is here, so he is present, but he will not be presenting today. I hope that's not too much of a disappointment. If it is, again, reach out. We will find a solution, and there might be an option for Brian to give you a private session. We'll figure it out. Okay, so in order to get out most of the sessions, be aware this is a level 400 session, so it's supposed to be very technical. So we will be looking at logs. So you should already have heard of Lync. Well, it's called Lync Conference, so I hope you have heard about Lync before. But as well, you should understand how SIP and signaling is really working, what's RTP, what's RTCP, and what is a typical Lync topology. I'll try to give as much context as possible, but you need to have an understanding of that to get out most of this session. There are a number of terms and acronyms that I will use throughout the session again and again, and I want to introduce them here. I will introduce them again when I use them the first time. But one of the very important concepts when we talk about media connectivity is the concept of a candidate. Every time I speak of a candidate, what I mean, it's a combination of a specific IP address and a specific port, and that might be a potential, well, it's called a candidate, a combination of port and IP that we are going to use for a media connectivity. We will also talk about ICE. ICE is the Interactive Connectivity Establishment, and the two protocols called STAN and TURN. STAN, initially called the simple traversal of UDP through NET. Over time, people figured out, well, that's actually a very smart protocol. Why use it just for UDP? We might also use it for TCP, but now we need a new name for it. Let's keep the same acronym. Let's just come up with different words behind it. So now it's called Session Traversal Utilities for NET. Important thing is NET. So we want somehow to overcome NET using STAN. And TURN, finally, is traversal using relay NET. The more important word, the NET, in this one is the relay. So every time we talk about TURN, there will be a relay, but there will be more in the following slides. So let's start out with the challenge. We have two users. These users are Alice and Bob. Alice and Bob are somewhere on the internet. And this is, so far, this is not Lync specific. This is really just they want to have some connectivity to each other. They want to exchange media. It might be audio, it might be video, whatever it is. But they are on the internet, and they want to call each other. So the first problem they have, well, Alice doesn't really know, is Bob online? Is he active? Where is he? So they need to register somewhere and say, well, I'm here. This is, you can connect to me. So what we need first is some kind of registrar. So let's put it there. The registrar might not be on the public internet. It might be somewhere in your corporate network. So there are firewalls, an internal firewall, an external firewall, so that we can build a perimeter network. And then let's put in there a SIP proxy, so that now my external clients on the internet can connect to this SIP proxy, and now they have signaling to each other. So that means they are aware that they exist, and they can talk to each other, exchange signaling information. And if they want to do a call now to each other, well, they can just have a call. Fantastic, no problem here. Well, there might be a problem. This will work as long as both of these endpoints have public IP addresses that allow to have a peer-to-peer connection. But most of the time, we don't have this situation. So most of the time, Alice and Bob might be sitting behind NET devices. So Alice and Bob, they might be sitting at home, at their respective homes, and they might have a wireless access point. This wireless access point will work as a NET. In the next slide, we'll go into a little bit more detail what a NET is and what it does. But basically, that means peer-to-peer connection, most likely not possible. So that's problem number one. But there are even more problems, because there might be a third user called Charlie. And Charlie, he's sitting inside the company. So he's connected to the internal network. He registers as well. And now Charlie and Alice want to have a call. Well, and now we have the problem that we have these two firewalls, and most likely they will block the call, so Charlie and Alice will not be able to have the call. And this is the problem that we need to overcome now. So let's look into the details of these two challenges. The first one, the NET device. NET, Network Address Translation. And it's a fantastic technology because it gives you security to some extent, but also it gives you the ability to have only one public IP address and a lot of private IP addresses. And if you think about your home, that's fantastic because you have your internet service provider. They give you internet access, give you one IP address, and then you connect all your devices, your PCs, your Xbox, your phones, your TV. Everything is connected. They have private IP addresses. To the public, you have only one IP address. If you want to access any information on a server on the internet, that's great. You open your connection outbound to the internet. The NET device is aware of that, and any response that's coming back to the NET device will be sent to the device that sent the request. And if someone just wants to send a request to you that was not initiated from your internal network, well, the NET device will block that because it just doesn't know where to put it to. So that's actually giving you some security because random packets from the internet, they will not be sent to your endpoints. However, in the context of communication, that's really bad because if Alice now wants to call Bob and there is a random packet coming from Bob to the NET device, it will not be sent to Alice and we will not have a conversation. If we talk about corporate firewalls, perimeter network, it's quite similar, the problem. It's a little bit different, so we have these two firewalls, the outer firewall and the inner firewall, and usually the way firewalls are set up is that someone from the internet can send traffic to the perimeter network, well, on specific ports, using specific protocols, most likely to specific IP addresses. So can send to the perimeter network, but can never send to the internal network, because then they would just skip the perimeter zone, would be pretty useless. The other way around, exactly the same case. Someone on the internal network can send traffic to the perimeter network, but they can never send directly to the internet. So again, if Charlie and Alice want to establish this call, it will be blocked. We have already seen that for signaling, we have a very simple solution. We just have this SIP proxy. It's static, it's always there, and all of our SIP traffic we can send to the SIP proxy. In theory, we could do the very same thing. We could do the very same thing for audio-video, but if there would be this static server where we send all the audio-video traffic to, that wouldn't be the smartest thing to do. Because if Alice and Bob would actually be able to do a peer-to-peer connection, well, that's much better. We want to do peer-to-peer if we can. Only if we cannot, we want to send it to a proxy. If we send it always to a proxy, it means, well, the call will have more delay, because now you have this additional hop, but also there will be a lot of load on this proxy server, because every single call needs to go there. And that is networking load, that's computing load on the server, so we don't want to do that. We need something smarter. So let's put all of that together. On the very left side, you can see our external network, well, our external client. Then you can see the net device that this external client might be sitting behind. You can see the outer firewall, the SIP proxy, the inner firewall, and the internal client. The signaling, here the green line, they can do that to the SIP proxy, so signaling, not a problem. If they want to establish a call, and this is the first time we see our candidates, so it's a combination of port and IP. So the external client has this candidate A, the internal client has this candidate W. If they want to do a peer-to-peer connection now, it will break, because W, the internal one, cannot send to the external one cannot send to the internal one. So that's exactly the problem. And the smart solution here is to use this interactive connectivity establishment and stun and turn, and we add an AV Edge server. And our AV Edge server has actually two components. First, it's a stun server. Second, it's a turn server. The stun component helps us to, well, it's to discover our reflexive address, to tell Alice, the external client, what the public IP address is. Alice is only aware of the candidate A of this local IP address. Alice is not aware of the public IP address that's sitting on the net. So by sending a packet to the stun server can tell us, well, actually, Alice, if I get a packet from you, this is the public IP address I can see, and maybe you can use that as a candidate. That's the first part. That's the stun functionality. The second part is the turn functionality. So it might be possible that we can communicate directly to the net device, but if you think about Alice and Charlie, one being internal in the organization, they will never be able to connect to this stun address. They need to have a relay. So that's where turn comes in. So the turn server also gives us candidates so that we can use, if we have to, the turn server as a proxy. Traffic flows, media call completes, fantastic, we can do that. All these three protocols are based on IETF standards or drafts of those, so these are industry standards. Other vendors are doing similar things. This is proven technology. So let's take a look at a typical Lync environment and think about which components in my environment are actually doing ICE. You can see on the very left again, there is the external network. I have there my public providers, Skype. I have my federated users, my remote users. Then I have a perimeter network. And then on the very right side, I have my internal network, internal endpoints, my front-end pool, and my PSTN components. So the Lync client is an ICE endpoint. Every time I want to do a media call from Lync to Lync, they will do the ICE process, and we will learn about the ICE process in the following slides. So Lync client is an ICE endpoint. Lync mobile client is also an ICE endpoint. Every time you call a Lync mobile client, they will, over the AV Edge server, do the ICE process. So this is also an ICE endpoint. And if you want to learn more about the mobile client, there was a session today in the morning by my colleagues Kaushal and James. You can go and watch the recording. At the end of the session, I have some related sessions, and you can find the session code there. So yes, mobile client is one as well. Lync Phone Edition, ICE client as well. Every time you call Lync Phone Edition, that's what's going to happen. Lync Web App, yeah, sure. In Lync Web App, we have audio, we have video, we have desktop sharing. Lync Web App is an ICE endpoint. What about Skype? Any ideas? Yes? Well, maybe. So today, Skype is not an ICE endpoint. The way we're doing media connectivity today with Skype does not use ICE, but as we evolve and as we're going to start adding more capabilities, adding video to Skype, it will adopt the ICE technology. So soon it's becoming an ICE endpoint. Again, not today. There's also a session on Skype deep dive, how that works. Again, there's a reference at the end of the session. Front-end server is an ICE endpoint because it runs a lot of services that are doing media, auto attendant, application sharing MCU, audio-video MCU, all of that ICE endpoints. And for the sake of this session, when we think about ICE endpoints, ICE clients, I don't really care if it's a server or a Lync client endpoint. From the ICE perspective, they are all just clients, no matter if it's running on a server or not. So yes, there's a little ICE cube there. Then Exchange exact the same thing. It's an ICE endpoint because we can call audio call to Exchange and that will be using ICE. Mediation server, again, it's using ICE because it's doing media. Maybe before I go to the Edge server, if we're thinking about gateways are not doing ICE. Even if you're doing media bypass, there will be no ICE negotiation. So that's also one of the reasons why if you're doing media bypass, it will never work over the Edge server because it's a pure peer-to-peer connection. There's no added logic about ICE and how to do that. So gateways are not doing ICE. Edge server, what about the Edge server? The Edge server is very important for all our ICE process, but it's not an ICE endpoint. It does not terminate any media. So because it's very important, it has this stun and this turn functionality. That's why we have these two little arrows. And yeah, I decided to put soft ICE there because, again, it's quite icy, but it's not ICE. Summary here, ICE endpoints can be clients and servers, and every time you terminate media, we will see ICE. And that will be audio, video, desktop sharing, or application sharing. If we are doing file transfer, that's also using ICE. PowerPoint sharing, though, uses different technology. The Edge server itself provides stun and turn functionality. It does not provide, it is not an ICE endpoint. So now we know why we want to do ICE. Now we know what components are doing it. So the next step would be, well, how does it work? How does it look like? And ICE consists of 5 phases. The first phase you will only see during the sign-in of a client or when you start up a server. And then to refresh the credentials, we will see that. That's about requesting a token so that the endpoint is allowed to use the so-called Media Relay Authentication Service, the MRAS. So basically, when we sign in, we learn about this is the Edge server to use, and here's a token that will enable you to use the Edge server whenever you need to. Happens once. And then, when you establish a call, every time you establish a call, you see the following 4 phases. Example is Alice wants to call Bob. So when Alice presses the call button, the client does not send anything to Bob yet. The first thing that the ICE process does is needs to find out where could Alice be reached. Needs to find all the potential candidates where Bob might be able to talk to Alice. If we have that, then we will send all this information to Bob, telling Bob, hey, Bob, I want to call you, and this is where you can reach me. At this point of time, Bob will do the same. Well, I need to figure out where Alice could reach me, send that back to me, so that would be the candidate exchange. And then they do connectivity checks. They know where potentially they could reach each other, so now they need to test where they can reach each other, and then finally they will pick the best candidate, the optimal candidate, to establish a media connection, and they will have the call, and we will look into all of these steps in detail. So this is about getting the credentials, getting our MRAS token, and in our example here on the very left side, we have our endpoint, then we have our outer firewall, we have our access edge server and AV edge server, we have the inner firewall, and we have the front-end server. For an internal client, we would do exactly the same, but it would go straight to the front-end server and would not go over the access edge server. So one of the first things that we are doing when we are signing in is we're sending a zip register telling the server that we are there, and then the zip register front-end server sends us back a 200 OK with all the in-band provisioning. The in-band provisioning is basically giving the client the configuration. You can see all kind of information there. Meeting size, normalization rules, what capabilities are enabled for the client, and also the client will learn what is the edge server that the client should use. So now the client knows that there is an edge server configured, then it sends a zip service request via the zip channel over the access edge server to the front-end server. The front-end server now sends a service request to the internal interface of the edge server and requests on behalf of the users this MRAS token. The edge server takes the certificate that we have on the edge server, creates the token, sends it back as a 200 OK, and this will be sent from the front-end server to the endpoint with some additional information. So as you can see here, the endpoint will learn the host name of the AV edge pool. So every time the client wants now to start a media call, it knows, well, I need to go, in this example, to edge.contoso.com. That's the external FQDN of the AV edge pool, because this is an external user. If it would be an internal user signing in, then the user would learn the internal FQDN of the edge pool. We are also learning what ports to use. So in this case, it's the UDP port 3478, the TCP port 443. I get a username and password. That's my token that I will need to authenticate against the AV edge server every time I use it. And there's a duration. It's 480, that's minutes. So this will be valid for 8 hours. That means after 8 hours, my client will and go request credentials again. So why do we need to go to the front-end server and then the front-end server is going to the edge server to get these credentials for us? Well, it's quite simple. The edge server is not part of my Active Directory domain. The edge server is not able to authenticate me as a user. The edge server doesn't know who I am. However, the edge server is configured, because from the topology it knows, I have this front-end server, and I can trust this front-end server. And the front-end server has a certificate, so I can validate that it is really the front-end server. Also, the front-end server can validate the certificate of the AV edge server, so we have this trusted relationship. So the client is authenticating against the front-end server, and since the front-end server can now trust the client, it gets these credentials on behalf of the client and sends it back to the client. For anonymous users, we also need to enable them to join meetings for audio, video, well, for media in general. So it looks quite similar. When an anonymous user joins a meeting, connect over the access edge server to the front-end server. The front-end server validates that, yes, this user should go into my meeting. The meeting key is valid. Goes again to the edge server. Edge server uses the certificate that's on the AV edge server to create the token, sends it back to the front-end server. Front-end server sends it to the user. The only difference that you can see here is that in the hostname field, we are now not sending an FQDN. We are sending the IP address of the specific AV edge server that will be used for this call by this user. The reason is it's just a little bit improvement in performance, because now the other endpoint doesn't need to go to DNS and resolve that. We already know that this this AV edge server is active at that point of time, and the external client can directly connect. Okay, let's take a look to see how this looks in a log, what we can see there. So what you can see here is the snooper tool. Who has used the snooper tool before? Well, that's everyone, almost. If you just raised your hand because you were embarrassed, that's okay. You can find the snooper tool. You can download that. It's part of the Lync 2013 debugging tools. It's a fantastic tool because it will make it very, very easy to read zip log files. The log files that the clients are creating, so we are looking here at the client log file. The log file is basically a text file. You could read it in Notepad. But the snooper tool does all this nice formatting where it shows you, well, it highlights the red, an error. If you click somewhere, it will highlight all the the other messages that are part of this dialog. So it makes it really, really easy to read log files. What I did here to create this log file, well, I just signed into Lync. So I did not anything special here, just signed in. If you want to test it yourself with your Lync client, just get sure to enable logging. And you want to always, if you want to see these specific steps, you want to create a new log file. If I would be already logged in for 5 hours, it's quite possible that my log file wouldn't have this information anymore because once it's full, it kicks out the old information. So create a new log file, sign in to see this information. And what I want now to see now is really how I get these MRAS credentials. So what I'm going to do here is I'm just searching for the term MRAS. And usually, if everything is configured correctly, then you should get 3 results. You should get this 200 zip OK. This is the incoming in-band provisioning, where the server tells me about all the configuration. So if I look now here on the right side, where you can see the details of this specific zip message, let me zoom in again. I can see here, for example, the port ranges that are configured. I can see here, so port ranges. I can see here more port ranges. Basically all the information so that my client knows what it is allowed to do. I can see here the maximum resolution for videos and so on. What I'm interested in is really the MRAS information, so I'm scrolling down. I can see here something is highlighted in yellow. And I can get here the information that there is an MRAS URI configured for my user. What I can learn from this, in the sense of troubleshooting, what I can learn from this, if I can see this line, it means on the server is an AV Edge server configured. That's all I know. I don't know if this Edge server is running, if there's connectivity, but I already know there is an Edge server configured. So if you're ever having problems with an AV call and you don't find this line, well, then your Edge server is not configured for the pool. Perfect. Then I look at the second message. And the second message is this zip, this service request where my client just tells the front-end server, dear front-end server, please get me credentials. Here's, by the way, some information about me. So my identity is I'm thomas.binder@skypeprograms.com. I'm at the internet, that's my location, and please get me credentials for the next 480 minutes. If you're looking for MRAS and you find the first entry, you will always see the second entry. I've not ever seen a single instance, a single problem where the second entry wouldn't be there. What's more interesting is the third one. The third one, the 200 OK, this is basically now the response of the server that tells me my credentials. So again, I can see here what's the username, but I can see here all this interesting information, the credential response that has a username and password. So username and password, that's my token. I have here my duration, and I can see here, I can see here my location, my host name, and my UDP port and my TCP port. If I can see this line, I know that my front-end server is able to communicate with my AV Edge server. We're using port 5062 here. It's zip. If you don't see that, then you will see error messages, and that tells you, well, for some reason, your front-end server is not able to communicate to the internal interface of the Edge server. Still doesn't mean that my client will be able to connect to the Edge server. There might be still other problems. What you also can see here, and what's very important, is the host name. I had just last week a colleague who called me and said, well, I have this problem. My endpoints, they cannot do any audio video calls, not working. We looked here at the MRAS. We found out that the host name that was configured was wrong. That means did a typo in topology builder, and that's why the clients were not able to find the edge server, because they just didn't register the DNS name with the typo. So that's already quite interesting for troubleshooting, and this is the information that I get, and now my client knows, well, there is an edge server configured. Whenever I need to use it, I go to av.skypeprograms.com, I use these ports, and I have this username and password. So going back to the presentation. So that's step one. Every time we sign in, every 8 hours, we need credentials. But now I want to do this call. I want to call someone. So this is the address discovery. So before I send any information, before Alice sends any information to Bob about calling them, she wants to know, well, how could I potentially communicate with Bob? And here on the very left side, you can see the endpoint. Then you can see the net or firewall, and then the AV edge server. The first candidate that we will always find are local candidates. So if Alice has, well, hopefully she has a network card, otherwise that would be over pretty soon. So we will find this first candidate, that's the local IP address with the port, and that's the first that we find. And then we will be talking to our edge server to allocate candidates, and you can see here, we do that for UDP, and we will find 2 candidates. The reflexive one, that's candidate B. So we send this IP packet to the AV edge server, and the AV edge server sends us back a packet and says, well, dear Alice, every time I get a packet from you, I can see actually IP address B. So your public IP address is B, and depending on your net device, how it's configured, maybe others will be able to communicate directly to B. However, in case you will not be able to use B as for your media session, there's also this candidate C. That's a candidate on the relay. That's representing the IP address of the edge server plus a port. So in case you need to use that, here you go. And then we do the same for TCP. For TCP as well, we have our reflexive candidate, we have our turn candidate. What we're not doing for TCP is allocating a local candidate. So the local candidate will always UDP only, because we are assuming if you can do a peer-to-peer connection, you can do UDP as well as TCP. We always prefer UDP. This is real-time communication. If we don't get a packet, please don't resend it. I'm not interested in that anymore. So UDP as a stateless protocol, much better. And all of that is true for audio-video. Not so much for application sharing and file transfer, because application sharing and file transfer, as Lync is doing it, it's based on TCP. So the process is the same, but now we only discover TCP candidates. So in this case, on the local network card, it's a TCP candidate, and we only allocate TCP candidates from the edge server, so our candidate list will be much shorter. There are also some other sources, well, actually one other source. If you have multiple network cards installed, virtual or physical network cards, every network card will create a candidate, and you will see these candidates in your candidate list, because they might be actually connected to other networks, and it might be possible to communicate over them while it's not able to communicate over others. And what's happening now in the client is, so I just said, well, Alice pressed the button and she discovers the candidates. That's happened already. So Alice is here on the very left side. She has discovered all these candidates. Then we have our firewall, our net. Then there's the edge server. And then there's the other person's edge server and the other person's firewall and the other person's client. And they could be part of the same company, could be part of different companies. The process will always be the same. So after Alice discovered the candidates, she sends a zip invite packet to Bob, including all the candidates, and telling her, well, actually, I want to call you. Obviously, this diagram is highly simplified. The zip traffic would never go from one endpoint to the other. It would go from Alice to her access edge server to her front-end server, then depending on the scenario, federation route, so on. I hope you get the picture. But from the idea, conceptual, the zip packet goes from Alice to Bob. So the zip invite goes there. So now Bob knows, hey, Alice wants to call me, and she has all these nice candidates. So let me find my candidates, and let me send them back to Alice. So you will see this 183 session progress. including the candidates. At this point of time, Bob did not answer the phone. He did not pick up, but we already want to establish a media session. Why? Because as soon as Bob picks up, he will say something like, hello, and we want to get sure that there is already a media session in place so that Alice can hear that hello. If we wouldn't do that, Bob would pick up, and then we would start to establish the media session. He would say hello. Chances are very high that this hello wouldn't go through, and then it would be a very awkward start in a conversation because Alice would be like, is already some, yeah, you know. It wouldn't really work. So early media, we're establishing at this point of time already the communication, and then eventually Bob will pick up. We send again a 200 OK. So this is the endpoint that we are using, and send the full list of candidates again, and have now the set that we will be using for this call or the potential candidates. And let's take a look at the log, how that looks there. So what I'm going to do now is I will just search for the word candidate, because then I will find all these interesting things. And what I did here in the call is I called my colleague Cornel. So you can see here, the first thing that we are seeing is, the first thing that we are seeing is here this out invite from me to Cornel. So here I press the call button. My client did already the address discovery. Now I send it over. And if I look here on the right side, I can see here all kind of interesting information. So this is the invite that I'm sending out, and the interesting part here is that this is the session description protocol, the so-called SDP, so that you can see that here, SDP, and that basically describes my capabilities, what I can do. So I'm telling him, I want to call you, and this is what I can do. So some people remember SDP by calling it self-description protocol, because that's basically what it does. It describes me, what I can do. And if I scroll down here, I can see all kinds of interesting stuff. I can see here all these candidates that we just spoke about. I can see here all the codecs that I'm supporting, so I'm really telling the other person what I will be able to do. And if you scroll down a little bit, then you can see that this whole block of candidates is there actually 2 times. The reason why it is there 2 times is during the evolution of Lync and OCS, the format changed. At the point of time where I'm calling Cornel, I don't know if he's on an old client, that would be OCS 2007, or on a newer client, OCS 2007 R2, Lync 2010, Lync 2013. So to be sure that he will be able to respond to the call, I just send out both. The first one that you will see in the log is this one, and it has this MS Proxy 2007 fallback. So this is the old format. And if you look here, down here on the format, the information, most of the information is the same, but it's not as easy to read. So for my purposes, if I want to do troubleshooting, if I want to understand what's happening, I always go to the new format because it's much easier to read. And this is what we are going to do now. So this is the candidate list for the new format. And I want to look now at the specific candidates one by one and address what I can see here. So the first thing I can see is that candidates, they have always this first number there, and that's always the same for 2 of the candidates. That's because candidates come in pairs. We use 1 candidate for the RTP traffic, for the real-time protocol, and 1 for the RTCP, for the real-time control protocol. So first learning, candidates always come in pairs. The second number just indicates which one is which one. So the first is RTP, the second one RTCP, and then I can see the next good information, UDP. So apparently, I'm looking now at a UDP candidate. And then I get this really long number. That's probably the only part that's not that easy to read. That's the priority. The higher the number, the higher the priority. If you would copy that into an Excel table, you would easily see what's the highest number. I'm telling you now, a local UDP candidate, that will always be the highest priority, so this is the highest number. But let me continue. Then you can see an IP address, and that's the IP address of this candidate. Next part is the port of the candidate, and then the type, type host. So this tells me this is a local candidate of the host. I have here only one host candidate, so apparently, well, I have only here one host candidate IPv4, so apparently there's only one IPv4 address on my machine. So if I'm going to the next line, I can see here, this format is a little bit different. It says here A equals X dash candidate. I didn't have the X dash before. The reason is this is an IPv6 candidate, as you can see here after candidate. I don't know yet if my peer understands what IPv6 is. This might be a Lync 2010 candidate, endpoint that I'm talking to, so I want to get sure that I'm not sending something that he is not understanding. So I'm flagging that as this X dash candidate, and only if the other peer understands IPv6, they will use this candidate. If not, they will ignore it. Again, there's a first and the second one. Then it says UDP. There is a priority. Then there is the IP address in IPv6. There's a port and type host, and so on. I can see that there is a second IPv6 candidate pair. I have no idea why. I haven't looked into that. But what I want to look at next is the last candidate pair, number 8, because this has a type of server reflexive, SRFLX. So that's the server reflexive. That's my STAN address. When I connected to my edge server, it told me, well, the public IP address that I'm seeing is actually the following. And let me just clear that. So looking at this candidate pair again, server reflexive, I can see here this IP address, and this IP address is actually the same as the IP address before. This is how I know, well, I was using this local candidate to actually go get this STAN reflexive candidate, and the STAN reflexive candidate is this one, the 206. So my public IP address, well, at least the public IP address that my edge server sees is this 206 address. And we might be able to connect to that. Then there's a third type of addresses, and that's the relay address. And the relay address, that's really the address of the AV edge server, plus a candidate that the AV edge server allocated for me. So I can see here the IP address of my AV edge server. One other thing that might be interesting is that I see for UDP candidates, I just see UDP. But for TCP candidates, I have this notion of TCP passive and TCP active. A TCP passive address candidate is a candidate that I know that can receive traffic, it's passive, and a TCP active candidate, I know it's active, it can send traffic. And if you look at candidate pair, if you look here at candidate pair 4 and 7, you can see that this is exactly the same candidate pairs, exactly the same ports. The only thing is one is active, one is passive. Well, it's the same candidate pair. It just means I can send and receive from those, because they are, as you also can see, the relay address. This is my edge server. For my reflexive address, I have only the active one, because for the relay address, that represents my net. I know that from my net I can send traffic, but I don't know if the net can receive traffic, so we are not adding that to the candidate list. Something else interesting that you might see is that if I look here at this UDP candidate pair on the top, pair 1, that the ports for RTP and RTCP are different, while if I'm looking here at this TCP candidate pair, for example, candidate pair 4, the ports for RTP and RTCP are the same. The reason is we want to use as little TCP ports as possible, so we are multiplexing there using the same port. With UDP, we don't have the requirement, we can just use more ports, so that's okay. It's part of the protocol that we list both of them, so we just list the same port number twice. So in terms from the perspective from troubleshooting, how could that help me troubleshooting? Well, if I see all these kinds of candidates, then it means I'm good. There is connectivity now from my client to the AV edge server. If I would not see the reflexive candidates and the turn candidates, it would mean, for some reason, my client is not able to connect to the AV Edge server. If you see, for example, only UDP candidates, but no TCP candidates, it would mean, well, in general, the client is able to connect to the Edge server, but something is blocking the TCP traffic. Could be a firewall, could be a misconfigured load balancer. There are different options. If you see no UDP candidates, but you see TCP candidates, there are two options. Well, the one option is, again, misconfiguration. The other option is you're doing application sharing or file transfer. There are only TCP candidates in that case. So that's also very good to understand. And if I go, if I go now back to the list of SIP messages that I'm seeing here, we just looked at this out invite that I'm sending to my colleague Cornel. But then we said there will be a 183 response coming back to me. And if I look here at the log, I can see here that there are 3 183 session progress coming back. If I look into detail into them, I can see the reason. So, for example, I look here at the first message, and I can see here that the user agent is the Lync client. I can see here the full version of the user agent. If I look at the second message, I can see here that this is actually coming from UCWA, so that this is from a mobile device. And if I look at the third message, I can see here that this is also coming from UCWA, but it's actually coming from a different mobile device. So in this case, my colleague Cornel is signed in on the PC and on 2 phones with the Lync clients. With all of them, I'm exchanging these candidates. With all of them, I'm doing early media and creating this media session, because at that point of time, I don't know where it's going to pick up. Finally, Cornel decides to pick up, so I get this 200 OK. I can see here again that he did this from his full client. So you can see here the full client, and if I scroll down, I can see here the candidate that Cornel is sending to me, and I can see here that he's also sending an IPv6 candidate, but as you can see here, he doesn't use the X- anymore. He doesn't need to, because I sent him an IPv6 candidate, so he knows that I understand IPv6. Something else that you can see here is that there's only one SDP. We don't include the 2007 fallback, because he already knows that I understand the new one, so there's no reason to include the fallback. If he would have been using an OCS 2007 R1 client, then I would see only the old format. Pardon me? So the question is, which of the candidates did he actually use? At this point, no, I don't. All I got is he picked up, but the connectivity checks are not over at this point of time. We will talk about this in the next slides. So we exchanged the candidates. We already have the early media in progress, and this is basically the connectivity checks. In the Lync logs, in the zip log, you cannot see the connectivity checks. If you want to see them, you need to start netmon, and you can see all kind of interesting packets flying around. From the point of view zip logs, we don't see it. But what's happening in the background is that we test all possible combinations from all the UDP candidates to all the other UDP candidates, TCP to TCP. The Edge server can actually bridge between IPv4 and IPv6. So if you have an internal network and your user is using IPv6 and the external user is using IPv4, the Edge server can bridge between these 2 versions of IP. So we try to test all possible combinations, and then we sort them and say, well, which are the best ones? And as soon as we have, as soon as a pair established a successful connection, we add them to the list. We don't need to test it anymore. We will continue testing until we know which are the best connections. Because then there will be the candidate promotion. So out of all the working connectivities, we will say, well, this is the best one, and Lync will use the following logic. We will always prefer IPv4 over IPv6. The reason is, well, IPv4 networks are have very good routing today. IPv6 is not that common, so we are assuming that IPv4 would give you a better connectivity, a more direct connectivity than IPv6. Also, after making this decision, we will say, well, if it's more direct, then we prefer that over relay. So if it's possible to do a peer-to-peer connection, do the peer-to-peer, don't go over the relay. And then finally, we're preferring UDP over TCP. So if we have multiple direct connections or multiple connections anywhere, we would say, well, UDP is better than TCP. Then, and this is what we're going to see in the log again in a minute, is we will see these final candidates that were used for this specific call. And now we have a validated optimal media path. So let me jump back here to the demo, well, to the log. So I still have here the search open for candidate. And after the 200 OK, I can see here that there is another invite. That's the re-invite. And then I can see here that's another 200 OK. This is when we send the final candidates. If you want to test that in your lab yourself or in your production environment or wherever, note the following. This is the timer. And between the 200 OK and the re-invite, in this case, we had about 6 seconds. After someone already picked up and after you're having already a call, connectivity checks are going on. It is possible that while you have the call within the first few seconds, that it switches to a more optimal media path. So if you want to see that in your logs, get sure to have the call open for at least 10 seconds. Because if you just pick up and say, oh, it works, great, you might not see that because the re-invite might never come. OK, and now if we look at the re-invite, scrolling down, I can see here again the SDP, but much shorter one. It has only the final candidates. I can see here it's UDP. I can see here the port IP. And I can see, in this case, on my side, it's the peer reflexive address. Peer reflexive. Have we seen that before? No, we didn't. What we have seen was the server reflexive. That's the server telling us, well, when you connect to me, I can see this candidate, this combination of IP address and port. A peer reflexive is, depending on my net, if I'm sending now a message not to my edge server but to somewhere else, it might use a different port. Same IP address, but different port. And this would be the peer reflexive. So apparently here, during the connectivity checks, we have discovered a new candidate, same IP address, different port, and this is what we're going to use on the one side for the call. If I want to see what we're using on the other side of the call, I'm going to the 200 OK, zoom in again, and I can see here that on Cornel's side, we used actually the relay address. So in this case, we are using my client is talking over the net to Cornel's edge server, and Cornel is talking directly to his edge server, and this is how we have our media path established. Good. So now we have seen how the ICE process actually works, how we get this most optimal media path. So what we're going to do next is we are going to look into what are the different scenarios, the different call flows. And I have here this topology. On the very left side, you can see two home users. They are in their respective homes. They are sitting behind nets. Then there is an outer firewall. Then there is my AV edge server. And then there's the inner firewall. And then there are internal endpoints. Could be Lync, AV, MCU, Exchange, whatever it is. It's a Lync endpoint and a user. The first scenario that we want to look at is internal user calls internal user. So what's going to happen? As soon as user work 1 decides to call user work 2, we do the discovery. So user 1 discovers there's this local address and there are my candidates on the edge server. At that point of time, user 1 doesn't know that he or she will be talking to an internal user. So we are always doing the ICE discovery, even if the other endpoint is internally. And it could also be the situation that the other user, the user that is called, Bob, has internal clients and external clients, because he might have a Lync phone sitting on his work desk, but he's actually working from home. So we're always doing the ICE part 1, the discovery of candidates. Now we take all of that, send it over to Bob. Now Bob does the discovery, and next step is connectivity checks. So the first connectivity that we're going to try, sorry, the first one is direct to direct. That's the most optimal one. We want really that to happen because now we don't need to send traffic to the edge server. Everything is fantastic. However, if for some reason that doesn't work, we can still have a media call, just by the logic how ICE works. So the edge server, they will still try all other combinations. So if that doesn't work, we will still try to connect from UDP, from the edge server to the edge server, and for TCP the same. Obviously, if this is one single edge server, it wouldn't go on the wire. It would stay within the edge server. But it could be that these users are hosted on 2 different edge servers, that they are on the same pool but load balanced to different servers. So that would still work. What it means for you is basically, well, so the thing is, Microsoft, I like to call it the Microsoft Wonderland. Microsoft believes that customers live in the Microsoft Wonderland, and in Microsoft Wonderland, things like internal firewalls don't exist. So all our customers living in Microsoft Wonderland will always have internal peer-to-peer connections. However, if for some strange reason a customer would ever decide not to allow peer-to-peer connections, because edge server does what it does, the call will go through. And I want to be very specific about it. That doesn't mean that it's supported. It's just the way it works. It technically works. There are a lot of reasons why you don't want to do that. First of all, well, everything needs to go to my edge server. That means more load on the edge server for every single internal call, but it means also more load on the network, because instead of having maybe within the same office building from one floor to the other floor a peer-to-peer connection, now all the traffic needs to go to my data center and needs to go back. And that will also affect my call quality because now I will have more delay. So it's not a good idea to do that. It's just the way it works. Next situation. I have a user at home. I have a user at work. Exact same start. They discover the addresses. So the external user will connect to the edge server on port 3478 UDP, 443 TCP, and will say, well, please allocate ports for me, and now we're trying to do the connectivity checks. Obviously, peer-to-peer doesn't work because of the firewalls, but the home user will try to connect to the ports that the internal user allocated on the edge server to the 50K port range. If this port range is open, fantastic, call is working. If it's not open, well, then the user will just tell the edge server, I cannot connect to this port, so please, edge server, on behalf of me, you need to connect to these ports, and then it will work, and then I will have a connection. So that would be the UDP connection. Similar situation, I have 2 external users. They want to call each other. They do the discovery. First option, most optimal option, peer-to-peer connection. Think about it. You're here at the conference. You're in your hotel room. You're external. You call your colleague in a different hotel room. Depending on the network of the hotel, what they allow might be a peer-to-peer connection. Obviously, the most optimal case. Depending on the net devices, it might also be possible that you're sitting both behind nets, but they might actually allow a connection from net to net. So that would still be very good because nothing needs to go to the edge server. If, for some reason, that's also not possible, then we try to connect to the high ports on the edge server. Both clients would do that to the specific high ports, or if that is also not possible, no high ports, then Lync would just, this Lync client would talk to 3478. There would be a hairpin going to the other high port within the Lync edge server, and then I could still have a media connection. There's a question? So I didn't really hear everything. What I heard was single edge server. So I have here a single edge server as an example. So different Lync solutions, if they would, so you would be on Contoso and I would be on Lync. So okay, does it make it, let's generalize the question, does it make a difference to which Lync deployment a user belongs? No, it does not. So if I'm having a federated user sitting next to me and I want to send file transfer to them, they will do exactly the same. It's just IP addresses to them that they are trying to connect to. So we will do a peer-to-peer connection if possible. So federation uses all the benefits, gets all of the benefits of the ICE protocol. So that would be the scenarios. And what's also very interesting is how does the whole 50K port range really work? What do I need to open? Lots of questions, lots of confusion about that. And this slide is the attempt to explain that. And we will start a little bit with a history lesson. So this is OCS 2007. This is how it all started when we had a media relay for the first time. Scenarios, on the very left side, I have work user 1. Then I have the AV edge server of work user 1. Then there's the other scenario of Contoso, edge server, the user. They want to do a call. So what's happening first is work user 1 allocates the candidates, sends it over a zip to work user 2, allocates candidates. The candidates are allocated in the 50K port range. So every time you look at candidates, it will say 50,327, whatever it is. And these two AV edge servers will talk on the high ports to each other. If you would close the high ports, they wouldn't be able to talk to each other. So OCS 2007, high ports need to be open. Then, in OCS 2007 R2, this tunnel mode was introduced. Very similar scenario, or same scenario, but now the edge servers are a newer version. We are still allocating in the high port. So the candidates, if you look at the candidate list, looks exactly the same. It's a high port that we allocate. But the servers, the edge servers, have actually more logic built in. They try to send to each other over 3478 to 3478 a packet and say, well, let's see if you are an OCS 2007 R2 edge server or newer. Let's see if you can accept this packet, because if you can do, let's just tunnel everything over these ports so that we don't need the high ports. So this is what we are doing for UDP. So for UDP, we just need to have these ports open, and the servers will be able to talk to each other. Would be fantastic if we could do the same for TCP, but we can't. The problem is, well, UDP is a stateless protocol. That means we can have from one IP address on one port to another IP address on the other port. We can have as many connections as we want at the same time. For TCP, we can have exactly one connection. If we want to have more connections, we need to change one of these four things. So either the IP addresses, well, that's pretty hard because they are quite static. So we need to change ports. We don't want to change the destination port because that's usually how firewalls are configured, based on destination ports. So we are changing the source port. So every time we're sending a packet here, we will use as a source port one of the ports in the 50K range and go to 443. Again, in the candidate list, you will see the 50K port range. Even after you promoted the candidates, it will still say 50K, even if you're not using a 50K port for the actual communication there. What about interop? If a new server is talking to an old server, then looks very similar. We are trying to establish this connection to 3478. The other server will say, well, I don't know what it is, go away. And then we do the same for TCP, so we need to fall back to the 50K port range. So if you are talking to an OCS 2007 R1 server, 50K port is required as a destination port. Bringing that all together, the minimum for 50K is, well, if you're talking to OCS 2007, you need all inbound and outbound. But if you're talking only about OCS 2007 R2, Lync 2010, Lync 2013, it depends if the firewall administrator is interested just in the destination ports that you need to configure on the firewall, or also in the source ports. If they are only interested in the destination ports, then what you would configure is AV edge server external interface to any, to the internet, needs to be able to talk to 443, needs to be able to talk to UDP 3478, and the other way around, incoming the same ports. If the administrator is telling you now, well, but we need to configure the source ports as well, well, we can do that. The source port for the communication to 443 will always be in the 50K port range. And for UDP, it will be 3478 to 3478. For the incoming traffic, we need to accept any, because this is coming from the clients, and they will use the full port ranges. So that was the minimum requirement. What about the optimal case? Let's assume the port range is open here, so we have these two users, might be part of the same company or might be not. They want to establish a call. So for the sake of the example, they cannot do a peer-to-peer call, because maybe they're sitting behind firewalls. So they need to use the edge server. So one possibility would be that Alice connects to her server on 443.3.478, allocates 50K port range, and Bob can connect to that. Fantastic, they have a call established. One edge server is in the call, might be the other edge server, depends. If I decide to close the 50K port range, well, again, peer-to-peer for the sake of the example is not possible. Now they want to do the same, but now Bob cannot connect to the 50K port range. Also on the other server, Alice cannot connect to the 50K port range, so the only possibility to make this call happen is from one edge server to the other edge server, but now you have always two edge servers in the call. Is this a problem? No, not really. So I would never push the customer hard to do that, to open the 50K port range, but if the customer is receptive to the idea to open that, or if they had an older version where they had it already open, then I would ask them to keep it open so that they can benefit of the more optimal media path. In Lync 2010, I believe, we also allowed edge servers to be to use NET, and that introduced actually a new interesting problem. So think about the following situation. We have, again, Alice in the internet. She's on top. We have Bob on the bottom. He's in an internal network. And we have two edge servers here. And in this case, these are edge servers of the same pool, but we're using DNS load balancing. So we are load balancing these edge servers, and we are using NET. So on the external interface of the edge server, we have a different IP address than it's represented to the internet. So if they want now to establish a call to each other, well, so Alice connects, is load balanced to edge server number 1, connects to 443.3.4.7, allocates high ports on the other edge server. Bob connects to the internal interface, does the same, allocates candidates on the other edge server. Now they want to establish a call. Most optimal would be 50K port range is open. Alice could connect to Bob's edge server on the 50K port range. However, that might not be possible because for reasons outside of your control. Alice might be working at a customer. Customer might have an internet that does not allow to connect to random ports on 50K. So she might only be able to use 443 or 3478 outside of your control. So while this could be happening, not an ideal solution. So what will always work is that the two edge servers talk to each other from 3478 to 3478 or from the 50K port range to 443 TCP. And this is the important thing. You must allow this kind of hairpin on your firewall because the edge servers will always talk external IP address to external IP address. So the traffic will go out through the firewall back into the firewall. A lot of firewalls have a default setting of not allowing that because it could be some spoofing attack. For these IP addresses, you must allow that. Otherwise, you cannot use NET with DNS load balancing. Solutions, well, use public IP addresses, but that's probably not what you want to do. Mm-hmm. So if there's only a single edge server, then this whole problem would not occur because it would not send it to the internet. It would just stay on the edge server. It wouldn't be a problem. If you're using public IP address, also not a problem. This is really a new corner case that came up when people started to use DNS load balancing and NET and have these specific firewalls. One more thing that I wanted to address, certificate within the edge pool. So you might realize if you read the documentation, also if you install your edge pool, it will tell you very specifically that you need for the AV edge to use the very same certificate on every AV edge server in your pool. And this is the reason why. When the endpoint signs in, goes to the Access Edge server front-end connects to the edge server, media edge server, AV edge server. The edge server uses their certificate to create the credentials. it does not remember this token. It just uses the certificate. It then can use the certificate to validate that this token was created by the edge server. At the time the client wants to do a call, the client might be load balanced to a different edge server. So only if this other edge server has the exact same certificate, only then it can validate the token. So very important to always use the same certificate. And when we say the same certificate, I mean exactly the same. With the same private key, you need to export it, including the private key, and import it on the other machine. It's not just certificate created with the same parameters. It needs to be the same certificate. Okay, how does all of this help us troubleshooting? Well, I mentioned all of that already. First, look for the MRAS. If you don't see the MRAS, there is no edge server configured for your users for this pool. Second, if you don't see the MRAS credentials, if you see error messages, it means your pool, your front-end server, cannot talk to the edge server internal interface on port 5062. Might be a DNS problem, cannot resolve DNS name, might be firewall problem, whatever it is. You see no stun or no turn candidates, means that your client is not able to connect to the edge server, might be, again, a firewall problem, DNS problem, all these things. Hardware load balancers, deep packet inspection, all of these things might damage your packets and you will not get the candidates that you need. Sometimes you might also see that the turn candidates show a wrong IP address, and this is the case if you have configured the net wrong. So in Topology Builder, when you say, well, this server is using net, you need to provide an IP address. If this IP address is wrong, then you will see also these kinds of problems. Where can I find the logs? In Lync 2013, first of all, turn on the logging. Second, the tip, always create clean logs so that you can see all the steps. So delete your old steps, just reproduce what you want to do. And then go to percentage, local app data percentage, Microsoft Office 15.0, link tracing. That's where you find the log. I've really troubleshooted a lot of these problems. Most of the time, a client log, just ask them to sign in, just ask them to do a call. You will see a lot of information, and you will be able to troubleshoot most of the problems. Lync 2010 and earlier, again, turn it on. It's just in percentage user profile, percentage tracing. And in live meeting, I hope I will never see that one again. But if you do, you need to set a registry key to enable the tracing, and then you will find it in the same log. Search tips, MRAS, to find the in-band provisioning, to find see what are the credentials. A equals candidate finds the candidate exchange. A equals remote candidate finds the promoted candidates. I'm a very lazy person, so I just search for candidate and find all of them. More tools. There's a synthetic transaction that can test the AV connectivity, obviously just from where you're testing that. So it might be good to include that in your test suite if you use synthetic transactions, but it will not give you everything. Pre-call diagnostic tool is a tool that connects. It's a Windows modern tool, connects on your behalf to the edge server, gives you information like packet loss, jitter. Quite handy if you're in locations like that and you want to figure out, is it a good idea to call my boss, my client, my fiancé over this connection, or would I want to prefer a landline? Port query, telnet, nice tools. Most of the time I just use telnet so I can validate the TCP connection is working, so I can test, can I connect to 443, to 5061, are the ports open that I expect. Resources, the Office protocols, these are the so-called red books. The idea about the red books is that we want to enable partners to write their own clients, so they specifically in very detail explain how the Lync client interacts with the server. It's not easy to read, it's more like an RFC document to read, but it has all the details. So if you want to get really crazy about the topic, go there. And then finally, the debugging tools. So to sum it up, so we talked about why do we need this edge server? What is it doing? We talked about how it finds the most optimal media path, and how can we use these client logs to find out what's happening. So I hope that you think that's interesting. I think it's pretty interesting. I hope that you understand call flows now and that you are able to troubleshoot. but the most important thing, Edge is really awesome. It's a great part of the product. If you want to see other sessions, the first two, Understanding Lync 2013 Mobile Media Flows, Securing External Mobile Access, they are already in the past, so you need to watch the recordings. But then we have one on technical deep dive into Lync Skype video, Lync Meetings and Edge, why does it matter, why do I need it, and Meetings and Media, the detailed view. So all of them should have related content. I haven't seen any of the presentation, but I did a search on Edge and they come up, so probably they are related. And well, thanks a lot for attending the session.